calculus, and in today's lesson we're going to be given the cubic equation and we need to find the equation, in other words the cubic function. So let's look at the types, the conditions. All right, so let's look at the conditions that we need to look at on the cubic graph, right? So condition number one, right? We are given some cubic function, right? And guess what? In this cubic function, all the x-intercepts are given, all right? So we are given x1, x2, and x3. After you're given all those x-intercepts, another point is given, just a general point. It can be the y-intercept or it can be any other point, so at P. So what is the formula that we use for this condition if all the x-intercepts are given? So remember, the general function of a cubic function is f of x is equal to ax squared, ax cubed plus bx squared plus cx plus d. So we are going to start off with this equation because all the x-intercepts are given. So we're going to start with y equals a into x minus x1, x minus x2, and x minus x3. After you substitute all the x1, x2, x3, then you need to say at P. Substitute the coordinate P. Why do we substitute the coordinate P? We substitute the coordinate P to find the value of A and make sure the value of A that you get matches up with the graph. In this case, the value of A will be positive. So remember to get a positive answer for A. After the whole idea of substituting a value of P inside is you're going to substitute X and Y values. So you will get an answer for A. Okay. After you get an answer for A, put the A back inside the equation, right? Open up everything and get it into this standard form. Okay, so that's condition one. Condition two is we have some cubic function, right? We have some cubic function, but the cubic function is now, the turning point of the cubic function is hitting the x-axis, right? It's on the x-axis. One turning point is on the x-axis. In other words, you only have two x-intercepts now. You got x1 and you've got another one here, x2. Okay. So now you're going to start off with this equation. You're going to start off with y equals, and obviously you're given some other point. So you're going to start off with y equals a into x minus x1, right? And what did I tell you when the turning point is on the x-axis is twice. So you're going to say x minus x2 squared, right? The square is very important. And you're going to say at P. So there's some other point P. P can be anywhere along this line, but it must be different from the x-intercepts. So at P, why are we substituting P to get the value of A? In this case, the value of A will be less than 0 because you can see the shape of the cubic function. So this is your second condition. Your third condition is a turning point is given. All right, so TP is given. And in most cases, when the turning point is given, you always have two equations, right? So if a turning point is given, it doesn't matter what type of turning point, whether you have a minimum, it's a cubic function, right? So it doesn't matter which turning point is given, whether it's a minimum or a maximum. So let me just put any cubic function here, right? So that's max, minimum, or you can have a cubic function going like this, right? So now let's just say, okay, let me choose any turning point from here. Remember, there are different types of turning points. So that's a maximum. I'm just choosing a turning point. Turning point is given. Turning point always has two equations, okay? So let's just say if the turning point is 3 and 4, for example. If the turning point is 3 and 4, your first equation, what are the two equations? The first equation is f of 3 is equal to 4, direct substitution. If I substitute the value of 3 in the original function, I will get 4. So f of 3 is equal to 4. This is the most basic knowledge. And the second equation is very important. The slope at the turning point, right? Or the gradient at the turning point is always 0. That's why when you're finding the turning point, we have to set the derivative equal to 0. And f prime 3 is equal to 0. So those are the two equations. And most of the time, we always, most of the time in this scenario, we always solve simultaneous equation, solve linear simultaneous equation, okay? Linear. We're going to end up solving these two equations, which will end up being solving linear simultaneous equation. Solve simultaneously, and then you can find the cubic function. We will do examples on based on each of these types, right? And the fourth condition is point of tangency. Point of tangency. Right. So they tell you that, okay, there is some kind of a cubic function, or it can be any other function. It doesn't have to be a cubic function, right? There's a cubic function and there's a tangent line. Right. So this is the F graph and that's the G graph. And the point of tangency is right here. Okay. So let's just call that point of tangency, point of contact, which is A and B. Or let's give it some values, right? Because most of the time you're given values. So let me just put 2 and 3. Okay. Now remember G of X, G function is linear. G of X will be a linear function. F is a cubic function. All right. So G of X is like mx plus c. Now, what is the point of tangency condition? Point of tangency condition is that f of 2 must be equal to g of 2. So at the x value of 2, this is the point of contact. At the point of contact, f of 2 must be equal to g of 2, and both the values will be 3. So f of 2 is equal to g of 2. This is equation 1, okay? And what's the second equation? The second equation is f derivative. F prime 2, the derivative at 2 is equal to the value of m. See there? The value of m. That's it. And even in this case, you're going to end up solving simultaneous equation. Solve simultaneous equation. Any questions, guys? So these are the 4 conditions for calculus. If you know these 4 things, you're sorted. All right. So now let's solve problems based on this. Okay. You find these types of examples given in the graphs. So if we go to question number 1, remember we're also going to revise some functions from grade 11, like hyperbola, parabola. Those are basic stuff, right? And exponential functions. Let's look at question number 53. Remember, this is our calculus lecture series. So we currently at question number 53 because we did lots and lots of derivative questions, which was very simple. That's the reason why we ended up at such a high number. Anyways, let's read the story and then answer the questions that follows. Right, so see what the question says. Find the equation of f of x. Given below, given the graph of f of x, all right? Okay, so we are given the graph of f of x with x-intercepts -2 and 1. So what's the x-intercept? -2 and 1. That value is 1, by the way. And y-intercepts at -4. So the y-intercept is -4. Right, the point 0, 5 and 3, 125 lie on the graph of f of x. So lots of information given. We didn't even need this point over here to find the equation of f of x, right? So I'm just going to use -2 and 1 and -4 here to find the f of x equation. So we're going to say y equals a into x minus x1, x minus x2. At x1 is twice because the turning point is on the x-axis. So twice here. And we're going to say at P, the point P that I'm using is 0 and -4, the y-intercept, okay? You can also use the other point, which is half and -3.125, but it should be -3.125, yeah. Half and -3.125, but that will be more difficult to substitute and solve. Anyways, let's solve this. So you got y equals what's x1? X1 is -2, so -2 becomes +2. X minus x2 is x minus 1, right? At the value of p, which is 0 and -4. Now we can substitute 0 and -4 inside here. -4 is the y value. A 0, x value is 0, right? So you're going to say 0 plus 2 squared into 0 minus 1. So we can see we're getting -4a is equal to -4. If you multiply all this out, 2 squared is 4, 4 times -1, so -4a. Therefore, the value of a is equal to 1. And you can clearly see the value of a is positive, which matches up with the shape of the graph, right? Now, since the value of a is 1, we're going to take 1 and substitute into this equation. Remember, the value of a is now 1. So the a value 1, you're going to substitute into a. So this implies you're going to have y is equal to, you don't need to substitute 1 now, just write x minus 1. I'm rearranging this. So I'm going to write x minus 1 into x plus 2 all squared. What is x plus 2 all squared? X plus 2 all squared. You have to open up this entire equation to get the standard form of the equation. So now we got x minus 1 into, if you're squaring this binomial, is a plus b squared, right? And you remember the formula for a plus b squared is a squared plus 2ab plus b squared. So square this x, you get x squared. Product of these two multiply by 2, so plus 4x. Square the 2, you get plus 4, right? Now we need to multiply everything out. X times x squared is x cubed. You know how you multiply it out? 3 times 1, 2, 3, and then take the minus 1, 1, 2, 3. Make sure you end up with 6 terms and then simplify. X cubed plus 4x squared plus 4x minus x squared minus 4x minus 1 times 4 minus 4. We have like terms, so nothing with the x cubed. 4x squared minus x squared is plus 3x squared, right? Plus 4x minus 4x cancels out. See, plus 4x minus 4x, that cancels out. And minus 4. I just want to put this into the calculator and see if I'm getting -2 and 1 as my only x-intercepts. Let's put it into the calculator to double check the answer. And a question like this is worth 5 marks, right? So mode, equation, and option number 4. What's the value of a? The coefficient of x cubed, which was 1, 3. Be careful, there's no x here. So 0. And the value of d is -4, which is the y-intercept. And see, I'm getting one answer, one x-intercept as 1 and the other x-intercept as -2. And that's the only one I have. Okay, so now I know my answer is correct. So there is a way to double check. Right, great. Next question. See what the next question is asking me for. Find the inflection point. Why? Because I already have the two turning points here. I got -2, 0 and 0 and -4. Those are the two turning points. That's the maximum value and that's the minimum. So what we want to find now is find the inflection point. Inflection point is double derivative, setting it equal to 0. So inflection point looks like it's going to be somewhere around here where the concavity changes, where the graph changes from sad to happy or from happy to sad. Is somewhere around here. I don't know what the exact value is because we need to solve it. The inflection point occurs somewhere around here because this is the point where the graph changes from sad to happy. Now, so inflection point is what is, okay, so we had y equals x cubed plus 3x squared minus 4. What's y prime? The first derivative gives us stationary points. So that is 3x squared, 3 times 1 is 3, take away 1 from the power, plus 2 times 3 is 6, 6x. But we don't want first derivative. Inflection point means f double prime x is equal to 0, or y double prime is equal to 0. So we're finding y double prime, right? So 2 times 3 is 6x, plus 6, this is linear, finding the derivative of this. What is the slope, or what is the gradient, which is 6, is equal to 0. We set this equal to 0, so we're getting x is equal to -1. If x is equal to -1, what is the y value? Y is equal to f of -1. We need to substitute -1 inside this function here. If we substitute -1 inside here, we will get -1 cubed, which is -1, plus 3, because 1 squared is 1, minus 4. So I'm getting -5 plus 3, which is -2. So my inflection point is now -1 and -2. And ta-da, that's what we have. And I told you the inflection point occurs somewhere around here. You must have a general intuition of where the inflection point will be. And we can see it is at -1 and -2. Any questions, guys? If you have questions, please ask. You can put your microphone on and ask at any point in time. Or if I make a mistake, please correct me. Thank you. Let's move on. Look at the next question. I like the next question because C, right? Part C, for which values of k will the roots of the equation have distinct roots? Okay, so I like this question because you need to draw horizontal lines to check how many times it's cutting, right? And why did they give this point here? Oh yeah, we want to find the equation of the tangent line at that point. That's the reason why that point was given. I'm going to add that question in. Right, so we want to find distinct roots, okay? I'm going to put all three questions here with the roots, right? And because you need to understand all three concepts, you will find it everywhere in the exam papers. Distinct roots, and then we want to find the other concepts as well. So I'm just going to do the first one, write the answer here, and then there and there. Right, so when will the equation have three different roots? Different roots you will have is, let me draw a horizontal line. Whenever you're finding roots, you are looking at y values. So look at this, f of x is equal to k. Right, so we first going to draw a horizontal line and move that horizontal line everywhere. So see, currently on the x-axis, it has two roots, okay? 1, 2. So you can say three real roots because that one is repeated. If I move it above the x-axis, in other words, above 0, if I move it above 0, the graph, this horizontal line is only cutting the graph once. And if I move it below the turning point, it's also cutting once, right? So we only focus on the y values of the turning points, all right? So now let's look at this. So obviously where it is cutting once is one real root. When will the graph be one real root? One real root will be above 0. You can see when you shift the horizontal line above 0. Well, look at the turning point, it is -2 and 0. So if I shift this above the turning point, so when k is greater than 0, or when I shift this horizontal line below the turning point, which is at -4, right? The y value is -4. You only need to focus on the y value of the turning points. So for one real root, focus on y values of turning points, right? TPs. So OK is less than -4. You can see the graph, the horizontal line is only cutting the graph once. OK is less than -4. So I'm done with one real root. What about distinct roots? Distinct roots will always be between the turning points. See, distinct roots means we want three real roots, okay? Distinct roots means all different roots. So all different roots you'll only get between 0 and -4. But we can't put smaller value down, so it's between -4 and 0. See, -4 and 0 sliding. The graph is always cutting 3 points. So between -4 to 0. And where am I getting -4 to 0? So see, this turning point is 0 and -4. if you write it in coordinate form, and that turning point is -2 and 0. So between -4 and 0, we always having three distinct roots. So between -4 and 0. That's my answer, right? Now, what happens when you are doing, okay, that was for distinct roots. What happens if you are doing a real roots? Real roots, all you need to do is just include this. Right. Why are we including it? Because if you take this there, you're going to have a repeated root. A real roots is more like you can include multiple answers, all right? So it's just including the, it means you're going to have identical root and another root. That's what real roots mean. So it's at the turning point, okay? So turning points are included. Only for distinct roots, turning points are not included. So I hope you understood that question. Anyways, part D, there's one more question here. Find the equation of the tangent line at point P. Let's call this point P. Find the equation of the tangent line at P. So we try to find the equation of this line here, all right? I'm going to draw it for you. So let's take a different color. We're trying to find the equation of that tangent line there. And it's very simple because this coordinate is given, right? So the coordinate is given, and we're just finding the equation of this tangent line. The equation of the tangent line is y is equal to mx plus c. But I don't like to use y equals mx plus c. I need to put it in this form. I'm going to use this one here, y minus y1 equals m into x minus x1. But we need to find m first. How do we find m? M is the slope or the gradient of this line, the tangent line. And to find the gradient of the tangent line, we need to find the derivative. So you're going to say f prime x. Isn't we had an f prime x? We did find the f prime x. I'm just going to copy and paste. So we got 3x squared plus 6x. Right. So f prime x is 3x squared plus 6x. Now, if I plug in values, if I substitute values inside x, I will get this is a gradient function, all right? What does f prime x mean? It's a gradient function. Now, if you put values in the gradient function, what do you expect to get? You expect to get the instantaneous gradient. You need to get the gradient at that instant. So I'm going to substitute at 0.5. So you're going to say f prime 0.5 is equal to 3 times 0.5 squared plus 6 times 0.5. Now you need to put this into the calculator and you will get an answer. So mod 1, 3 times 0.5 squared is half squared, which is quarter, 0.25. I'm not squaring, right? I already squared it. 0.5 times 0.5 is 0.25. 6 times half is 3, so plus 3. And I'm getting an answer of 3.75 or 15 over 4. So what's my gradient? This is my gradient at x is equal to half. Right. Now we use this formula here, the equation of the tangent line formula, and find the value of c. You don't need to find the value of c if you are using this formula, because you're just going to substitute this point P at half. X value is half, and what is negative 3.125? Just put negative 3.125, get the fraction value. Negative 3.125. That is minus 25 over 8, okay? Right, so now this is the x value, that's a y value. So the y value is minus 25 over 8. So y minus minus 25 over 8 is equal to what's m? Half into x minus, no, m is not half. M is, oh yeah, m is 15 over 4. M is 15 over 4 into x minus a half. It's just dealing with fractions. So y is equal to plus 20, y plus 25 over 8, because minus minus 15 over 4x, right? 15 times negative half is negative 15 over 4 times 2 is 8. You can multiply this out. 15 over 4 times negative half is minus 15 over 8. Now we need to take the 25 over 8 over. So y is equal to 15 over 4x minus 15 minus 25 is minus 40 over 8. And 40 over 8 is equal to 15 over 4x. What is minus 40 over 8 is 5. 40 divided by 8. Yeah, that is 5. Right, so minus 5. And you can see this, the equation of the tangent line is intersecting somewhere around there at negative 5. So this answer is correct. Okay. Yeah. So this is an answer. Right, so I hope you guys understood that. Right, let's move on to the next question. This is coming from the trial paper, KZN, and it was question number 10, right? So I'll put some references in the side here. You can have a look at it. So we are given the function. Remember, all the graphs are given. All you need to do, you're not sketching a function. Sketching function was done in lecture number 4, where you had to sketch all the different types of functions, cubic functions. Right, now we are finding the equation of the cubic function. See, they gave us some information here. They said h of x is equal to all this here, all this information. And we want to find c and d somehow. Then we can find the full function. So they are missing, yeah. So function is not complete. So question number 1, right? See, question number 1 is 5 marks, right? Now, how are we going to solve a 5-mark question like this? Show that c is equal to negative 18 and d is equal to 32, right? Now, how are we going to show that is you have to read the story, okay? And look at the information that's given in the story, right? It is sketched. So this cubic function h of x is sketched with turning points at a, which is x equals negative 2. So x equals negative 2 is the turning point, right? At a, we don't know what the y value is. And there's a turning point at b, which is at 3, okay? And we also don't know what the y value is. But the thing is that they told us what the turning points are, all right? And d as a 0.40. Show that c is equal to negative 18 and d is equal to 32. So what is c and d? C and d are these values here, c and d, okay? Now, because the two turning points, because the two intercepts are given here, right? Okay, so the turning point is -2 and 3. We are given -2 and 3. Okay, so what we're going to do, how would you go and normally find turning points from the cubic equation? You'll find h prime x, all right? You say h prime x, this is the way to find turning points, and you set this equal to 0. So I'm setting this here, the derivative equal to 0. So if I find the derivative, I'm getting 3x squared. 3 times 1 is 3. Take away 1 from the power. 2 times 3 over 2 is minus 3x, okay? Plus c is equal to 0, okay? So 3x squared minus 3x plus c is equal to 0. But now look at when I solve this equation equal to 0, this implies I'm getting two answers. My two answers are x1 equals -2 or x2 is equal to 3. I already know the answer because they're telling us that the turning point occurs at -2 and 3. So let's work backwards with this now. Take this over. I'm going to get x plus 2 and take this over. I will get x minus 3, right? Is equal to 0. Now, I will open up this entire equation and see what I get. So I will get x plus 2. So that is x squared minus 3x plus 2x is minus x. And 2 times -3 is -6, right? Is equal to 0. But compare this equation with that. But now I'm going to make it look like this by multiplying a factor. So I'm going to multiply by a, and I'm going to take this equation and multiply by a because it's equal to 0. You're kind of like multiplying by a on both sides. So I'm going to say the value of a here, in this case, this value here is already 3, right? So that's 3 into x squared minus x minus 6 is equal to 0. So if I open up this entire equation, I will get 3x squared minus 3x minus 18 is equal to 0. So now can you see what the value of c is? If you're comparing here, look at this value. This value of c is equal to negative 18 from the original quadratic. So this implies the value of c is equal to negative 18. So great, we solve for the value of c, which is negative 18. Okay? Now, all we have to do is find the value of d, right? And they said, look at this as the y-intercept and d as a point 40. So there's a point d which is given as 40. Remember this point here is given as 4 and 0. So now I'm going to write out the equation that I have so far, which is x cubed minus 3 over 2x squared. And the value of c was negative 18x, right? Plus d. Remember, all this is also the derivative. This is the same thing as saying h prime x, okay? So this is your function h prime x. That's the reason why we compared. We did a comparison and we got c value as negative 18 because see, this entire thing is h prime x. So if you equate this 3x squared minus 3x cancels out, 3x squared minus 3x cancels out. So you're just left with c, which is negative 18. That's why by comparison, we got that answer. Now we're going to write down h of x, which is x cubed minus 3 over 2x squared minus 18x plus d. Okay, so now the value of d is missing and we got c as negative 18. Now how are we going to show that d is 32? We're going to substitute the other point because we have already used up negative 2 and 3 for the turning point. So we're going to say at 4, 0. So what's the y value? 0. That is 4 cubed, which is minus 3 over 2 times 4 squared minus 18 times 4 plus d is equal to 0. So I'm just going to write, therefore, d is equal to, I'm just going to cheat here. I'm going to say d is equal to 32. Right, but don't do it like this. Just make sure that it's actually 32. Let's add up all these values and see if you get negative 32 there. Okay, so 4 cubed is 64. 4 squared is 16. 16 over 2 is 8, so minus 24. 18 times 4, that's 18. 36, 72 minus 72. So I'm getting negative 32 on this side. I take that over, you get 32. So we got the value of C of 18, value of D, which is 32. So we showed it, right? So now you have the full equation. Now with the full equation, you can find the turning points. You can find that turning point. We can do lots of analysis with the full equation. That's what we are doing. That's the whole purpose of the lesson today is to find the equation. After you find the equation, then everything is simple after that, right? See, now they're just going to ask you a basic question. We do 2 questions, 3 questions at a time now. Let me put the graph on this side as well and solve on this side. Solve on the, let me put the graph on the left and solve on the right. So put the graph on the left, right? So now what we want to find is calculate the coordinates of A. Very simple. To find the coordinates of A, you're just going to substitute minus 2 in the original function. So what's the original function? B. For B, you're going to say f of x is equal to, the original function is this, right? Now, remember, we already solved for the value of D, so I can change the value of D and put plus 32, okay? Right, so now this is my original function. Now I want to find the coordinates of A, but I already have the X value. So just find the Y value. It's very simple. Just substitute -2. So you substitute -2 inside here, the entire equation, you're going to say -2 cubed minus 3 over 2 times -2 minus 18x. Guys, I need some help. Use a calculator and solve all this and just give me the answer. Uh, you must start solving quickly. I just need you to focus and see if I'm doing everything correctly, right? So that's -8, -6, -36 plus 32. Oh, that works out. Value, the Y value needs to be positive. So I'm substituting -2 inside, so -2, -2 cubed to the power 3, minus 3 over 2 times -2 squared is 4, right? Minus 18 times 2 is 36, minus 36 plus 32. I'm getting -18. Calculate the coordinates of A. Why am I getting -18? Shouldn't be getting -18. X cubed minus 3 over 2 x squared minus 18x. Oh, the value of C is -18. I put, oh, okay. I'm making a mistake, yes. Because I put 2 here, supposed to be putting -2 there, right? You can see why I'm finding an error, because obviously this is sitting above on the positive y-axis. That's why I can't get negative. It's supposed to be plus 36 here. Make sure how you're substituting plus 36, all right? So I've got 54. So the answer is 54 here, right? So this here is equal to 54. So the coordinates of A is -2 and 54. Right, so that's done. Let's look at part C. Determine the x value of the point of inflection, only the x value, all right? To find the x value, obviously, we need double prime x. So what is h prime x? H prime x is 3 times 1, which is 3x squared. 3 over 2 times 2 is minus 3x. And this is easy, minus 18, right? We need to find h double prime x. We only want the x values. So 3 times 2 is 6. X minus 3 is equal to 0. So 6x is equal to 3. X is equal to half. Only the x value of the point of inflection, right? So the point of inflection, x value of the point of inflection, x is equal to half is somewhere around here. That's where the point of inflection is, right? Where the concavity is changing. Write down the interval for which h is concave up. When is it concave up? Because this value is half, right? Concave up means happy. When is a graph happy? The graph is happy after the x value, which is half, right? So the graph is all happy over here after half. So x is greater than half. That's where the graph is happy. Write down the interval. Okay, we want an interval. So x greater than half, write it in interval notation. X is an element from half to infinity. I think if you write x is greater than half, that should be fine, right? X is greater than half. It kind of represents an interval as well. So they kind of lenient with this. But because they said interval, so write it in interval notation. Just give them that half to infinity, right? Remember not to include half. And there's some transformation questions, right? And there's questions at the end as well. And that was a very difficult question at the end. I'll take this graph as well. I'll retake this graph. Each question has like a unique explanation, all right? So that's the reason why I'm taking this. Let's take this graph here, high up, all right? All right, so now let me do, if g of x is equal to h of negative x, So what are we doing? We're putting negative x inside h of x function. So we're kind of like flipping the graph. Are we flipping the graph? What happens if the x value becomes negative? So you need to look at the point transformation. Is this a reflection on the x-axis or a y-axis? So let's see. If this is the point P, which is x and y, if the x value is becoming negative, it means it's a reflection on the y-axis, okay? So remember, you are reflecting on y-axis. H of negative x, the x value became negative. So it's a reflection on y-axis. Reflection on y-axis. Then write down the coordinates of the turning point that is the image of A after this transformation is applied. So what was A? A was -2 and 54. Now, if I fold the y-axis, where will A move? A will go onto the other side. The x value will now become negative. So it will become 2 and 54. So the image of A is A prime, which is 2 and 54. The image of A, right? Because you are basically reflecting on the y-axis. If you fold the y-axis, the coordinate of A will end up being there, is not on that line, actually at 2 and 54. So that point will move there. That point will get reflected here. And what is that point? It's going to be at the x value of 2, not -2, 2, because you need to change the x to negatives. It was already a negative. If we put another negative, negative makes a positive. So 2 and 54 should be fine. Determine the values or value of k where h of x equals to k has two unequal roots where roots are of opposite side. Now, this is a very difficult question because it doesn't look like it's a value. It's a question that we have done above with the roots, right? So I'm going to explain this. Let's use a horizontal line and cut at the moment and then decide on what to do. Let's cut. But now how are you going to cut? You're not going to cut like this, the traditional cut where you're getting three roots. We want an answer here. First of all, we need to figure out what the coordinate of C there is. C is the y-intercept, right? The coordinate of C is the y-intercept, and that was, what was the coordinate of C? It was 32, the constant. So the coordinate of C is 32. Now, we're not using our traditional cuts. We want to cut in such a way that we're getting two unequal roots where roots are of opposite signs. Okay? So where must you cut? You have to get two roots, but it must be of opposite signs. So let's try cutting in between. If you're going to cut anywhere in between here, if you're going to cut anywhere in between the turning points, you're always going to get three roots, okay? But what happens if I cut at the turning point? We're not putting inequalities now. Are the roots of opposite signs if I cut at the turning point? Yes, there's one root here, which is at -2, and there's another root over here, okay? So we are going to say we're going to cut at the k value of 54. So the value of k will be 54. The value of k is 54. So if I cut at 54, I'm only getting two roots. One root is negative and the other root is on this side, which is positive, because remember this cubic function continues. You can clearly see that. Or where else must I cut? What about cutting here at the bottom? At the turning point, yes, that will also work because now this root is positive and the other root is negative. And that's why it was difficult, right? Because it wasn't traditional. Or k is equal to, what's the coordinate at B? Whoa, we got a problem because we still need to find the coordinates of B. Substitute the value of 3 inside here. So that's the value 3 and what's the y value here? We didn't find the y value, which is f of 3. We need to substitute 3 inside this cubic equation. So instead of -2, I need to substitute 3. That's going to be 3 squared, right? 3 squared minus 18 times 3, right? Minus 18 times 3 plus 32. Yeah. So that's going to give me minus 17 over 2 or minus 8.5. Let me just keep it as minus 17 over 2. So this coordinate here is minus 17 over 2, right? So, or the value of k is negative 17 over 2, okay? And those are your answers. So if I cut at those 2 points, I will always get what? Roots that are of opposite signs. So remember your when you're solving h of x equals to k, that value of k here is the y values that you're looking at. Okay? Are we good, guys? So I hope you understood everything. Any questions? No questions? That's excellent. Next. Right, so there was another question, that's Mpumalanga province, question 7 in the trial 2018 paper. Right. So I'm making references to the questions, so you can have a look at that as well, the complete paper if you want. Right, so let's read the story and then see what we need, right? Let me copy this into the next page. I keep on copying the graphs multiple times, right? Now, the graph of f of x is, you can clearly see there's 3 unknowns here now, B, C, D, but lucky the value of A was given there, right? The x-intercepts of f are -1, half, and 3. -1, this is half, right? And there's a 3 there. Points A and B are the turning points of F. A is a turning point, but lucky the B turning point is given, which is great. Point -2 and y lies on the graph of F, right? So that's just a general point. But now it's easy because 3 x-intercepts are given. Even the value of A is given, so that's great. So y is equal to, what's the first question? The first question should be to find the values of A, B, and C, right? Find the equation of F. 4 marks and 6 marks. So the bulk of the marks coming from there now. I'll paste the question here. So what we are doing now is finding the equation of F. So part A. Right, so to find the equation of F, you're going to say y is equal to A into x minus x1 into x minus x2 into x minus x3. But we already got the value of A, which is 2, right? And what's x minus x1? X minus, oh, wait. You don't put a 2 there. X minus x1, x minus x2, x minus x3. Yes, because how are you going to substitute half? No need to put an A there, okay? I'll tell you why, because you're going to put x plus half here, but you don't put half. If we put A here, it's fine. Okay, think about solving this equation. Forget about this. So y is now equals to A into x minus x1 is x plus 1. Now you don't say x minus half here, right? You don't say x minus half. You need to say 2x plus 1, 2x minus 1. Because if you solve 2x minus 1, that's how you're going to get x is equal to half, right? If you solve that bracket equal to 0. So you don't put x minus half here. You must say 2x minus 1. And this one here is a 3. So that is just x minus 3, right? Now you can clearly see if you open up all this, you're going to get 2x cubed. So no need to find, you can just say therefore, intuitive approach, therefore A is just equal to 1. In this case, it's not the same A value as here. Now, if the value of A is 1, then you can say y is now equals to 2x, open up the first two equations and bring the x minus 3 in the front. Or let's bring the 2x minus 1 in the front and open up this equation and that equation. So 2x minus 1 in the front, we're just opening up brackets, all right? So I'm putting the complicated one in the front and multiplying these two out. So that is x squared plus 1 minus 3 is minus 2x, right? and then minus 3. Now open up the entire equation and then you'll get 2x cubed, right? So you see 2x times x squared is 2x cubed. 2x times minus 2x is minus 4x squared. 2x times minus 3 is minus 6x. Minus 1 times x is minus x squared. Minus 1 times minus 2x is plus 2x plus 3. Now we're going to simplify. We will get 2x cubed minus 5x squared minus 6x, so minus 4x plus 3. Remember to always double check your answer, right? So this is f of x equation. How are we going to double check our answer? We're going to put all these values inside and check if we are getting these x-intercepts, right? So you're going to go to mode 5 and option number 4, the cubic option. So you're going to substitute 2, negative 5, negative 3, no, sorry, negative 4, and 3. Yeah, I'm getting x1 to be 3, 1 x-intercept. The next intercept is half, and the next one is negative 1. So perfect. That's my correct equation, right? Remember, the graph is not drawn to scale. Clearly, it's not drawn to scale because negative 1 can't be so far away and 3 can't be. So it's never ever drawn to scale. Next one. Given f of x, oh, they already told us the function is given like this. The reason why they give you the function, and because if you can't solve the first one, then you can kind of like cheat your way out from here. You don't lose all the marks here. So you see 2x cubed minus 5x squared minus 4x plus 3. So that is the correct function. That's the answer we ended up with. Calculate the coordinates of A. How are we going to find the coordinates of A? That is just derivative and set it equal to 0. And I don't know why 6 marks. It should be 4 marks. Right, so B. So we will find f prime x. Find the derivative. 3 times 2 is 6x squared. 2 times minus 5 is minus 10x. Minus 4x plus 3. What's this derivative of minus 4x plus 3? It's just minus 4, right? Because that is linear. Is equal to 0. Now, put it into standard form. So you're going to get 3x minus 5x minus 2 is equal to 0. This will definitely factorize because you got a 2 there. So clearly it's going to factorize into x minus 2 because one of the turning point is given, and the other one will be just 3x plus 1 is equal to 0. But you can just use a calculator to factorize this, and you'll get x is equal to 2 or x is equal to negative 1/3. So great. So we know the a value is negative 1/3. So what's a y value here? You need to substitute. So you're going to say reject here because we don't want 2. We want negative 1/3. So the y value is f of negative 1/3. So you're substituting negative 1/3 inside the function here, cubic function. So let's substitute negative 1/3 in the cubic function. I'm going to substitute here and show you. So 2 times mode 1, 2 open bracket negative 1/3, right? To the power 3 minus 5 into negative 1/3 to the power 2 minus 4 times negative 1/3, right? Plus 3. So I'm getting an answer of 100 over 27, which looks right because it's a positive y value. 100 divided by 27 is better to write it in decimal point, 3.70, 3.70, 3.70. So the coordinate of A is negative 1/3 and 100 over 27. You don't need to write it in this form. Only when you're sketching, because you need to know the exact, a point, not exact point, like an estimated point. So when you're sketching, then you can put negative 3.7 or whatever. Right, so that's your coordinates of A, right? Coordinates of A is negative 1/3 and 100 over 27. You can clearly see that is correct because the y-intercept is here, and that point is working out to be 3.7. So it is correct, the coordinate that we have here. All right, so far so good. Nice question. Continuing. Right, so they just ask you general questions now after this. See what they're asking you in C. Find the equation of the tangent in the form y equals mx plus c. So to find the equation of the tangent at point D, right? So you need to go and find point D first, right? So let's find point D first. because they want to find the equation of the tangent at point D. So you are basically finding the equation of this line here. I'm going to draw it for you. Okay, it's going to be difficult to draw because you will see that it's going like parallel. Yeah. So it's basically just a line which is upward sloping at point D. It's something like this. Uh, because the diagram not drawn to scale, it's hard to draw the tangent. See, it's like sitting on that. And so you're trying to find the equation of this line, but we need the coordinate of D first. The coordinate of D is -2 and y. So the value of y is f of -2. And f of -2 is substituting -2 inside here. So lucky I got this typed in already. So I can just edit this. Okay. -2. Let's edit this. -2 and -2 here as well. You have to get the value of y to be negative because it's sitting below the x-axis. -2. And we're getting -25. Perfect. Now we got a coordinate which is -2 and -25, which is the point of contact. That's half the problem solved. How are you going to solve the other half of the problem? You need to find the value of m. So m is equal to f prime what? The instantaneous gradient at -2. But we need f prime x first, right? So what's f prime x? I think we had f prime x. Didn't we find f prime x? The original f prime x. Yes, so we do have f prime x here. What does f prime x represent again? The gradient function. So if you substitute a value inside the gradient function, what does it represent? It represents the instantaneous gradient. Okay. Right, so great. Now we're going to substitute -2 inside here. So f prime -2, and that's how you're going to get m value, the instantaneous gradient. So 6 times -2, so that's 24. -2 squared is 4. Minus 10 times -2, so plus 20 minus 4. So that's 4. Yeah, that's 40. 24 minus 4. That is, remember we're substituting -2. Yeah, so that's 40. The gradient is 40. So it's a very steep gradient. I don't know why I made it like this. It's very steep. But now if I'm going to make it too steep, it's going to start intersecting. That's what I don't want you to see. Anyways, so now we're going to find y equals mx plus c. Let's try to solve it in this way. You must know how to use both ways. So y is equal to 40x plus c at -2 and -25. So y value is -25 equals 40 times -2 plus c. Right, so the value of c is that's -80 and that's -25. So that's going to give me that's -25 plus 80. So that's going to give me 55 because you need to move the -80 to the other side. It's going to become plus 80. So you are getting -25 plus 80. The value of c is -25 plus 80, which is 55. So therefore, the equation of the tangent line is 40x plus 55. Okay? At point D, the equation of the tangent at point D is 40x plus 55. Any questions, guys? Look at the next question. They're asking us, for which values of x will f be concave up? Concave up. Concave up. What is concave up? F double prime x greater than 0, okay? Concave up is happy face. So that's f double prime x greater than 0, okay? You can also find the concave up like this. You can add the two x-intercepts of the turning points, right? And find the midpoint of the x value. So it's somewhere around here. So see the x-intercept is 2 here, right? And that was -half. So 2 minus half is 1.5. 1.5 divided by 2 will be 0.75. So it's 3/4, right? But let's just find double derivative and make it positive. So we had a single derivative. Remember what was f prime x? F prime x was 6x squared minus 10x minus 4. So the double derivative will be 2 times 6 is 12. Take away 1 from the power, so 12x. Minus 10x minus 4, what is the gradient of minus 10x minus 4? It's just minus 10 greater than 0. Now we're going to simplify this. Sorry, it wasn't 3/4. Let's check. I think I put 3/4 here. What was the value of, what was the coordinate? Oh, this was 1/3. That was negative 1/3. Yeah, that was negative 1/3. Why did I say it's negative half? Sorry. That's negative 1/3. Okay, it's fine. I'll show you both methods, all right? So now what we have is we have 12x. We have here 12x is greater than 10. So x is greater than, divided by 12 both sides. 10 over 12 is 5 over 6. Therefore, x is greater than 5 over 6. So for which values of f will be concave of that? Or you can also solve the problem like this. You can take the, how do you find the x value of the inflection points, okay? That's what I'm showing you now. You can also solve it in this method. X inflection point value is stationary point 1 plus stationary point 2 divided by 2. What was stationary point 1? Stationary point 1 was negative 1/3, right? Negative 1/3. And stationary point 2 was 2. What's the stationary point? Where the graph turns, and divided by 2. You can also do it like this, but I just like the double derivative method, right? Minus 1 over 3 plus 2 divided by 2. So I'm getting 5 over 6. But now you're getting an answer, which is, this is not the answer. That's just the inflection point x value. So what is the answer? You have to look at the graph to get the answer. When is the graph concave up? So this is 5 over 6. The graph is happy when it's going after 5 over 6, okay? All that is. All right, so now we can get the answer. Therefore, we found the x value of the inflection point. So therefore, x is greater than 5 over 6. Same answer, right? You can use either method. But I like the derivatives method. It's much faster. I don't need to remember all these fancy rules, because sometimes this rule can fail. Yeah, it only works for x value. If you have two stationary points, then it will always work. But if you have a single stationary point, then you have a problem. Next question, very important, because this is the type of question that you need to focus on, and it's like higher order thinking, right? Because initially the problems are easy, and when you go towards the end of the question, then you just blank out. So that's what I don't want you to do, right? So it's a higher order thinking question. I need you to have full focus and see how we solve this problem. So first of all, see how the question is structured. Minus 2x cubed plus 5x squared plus 4x plus k is equal to 0 have three distinct roots. Okay, so for three distinct roots, we know what to do. So we know what the value of a was, negative 1/3, and it was negative 1/3, and what was it? Oh yeah, negative 1/3 and 100 over 27. That's what we had here. Okay, let's put this down. 100 over 27. But now look at this. This function is not f of x equals to k. Look at this equation. I need to put this equation in the form. What form? I need to put the equation in the form f of x is equal to, can't use k now, f of x is equal to L, and solve for L accordingly. All right, so we have a problem because I need to rewrite this function and match it up with this function. So what was the original function? The original function was this. Remember, the original function was f of x. The original function is this. This is my original function. Now, how is this function matching up with this function here? It's not at all. So you need to make this equation matching up with this function. So let's see. We got minus 2x cubed. So the solution here is minus 2x cubed plus 5x squared plus 4x plus k is equal to 0. Now I'm going to multiply the entire equation by negative to make it look like this, like this entire function. So I'm going to say 2x cubed minus 5x squared minus 4x minus k is equal to 0. Okay, so I multiply this entire equation by a negative so as to make it look like this. But now we are still missing a 3 here, okay? So I'm going to take this k over. If I take the k over, perfect. We got an equation in this form. But now there's something missing here. So I need to add a 3 because I need to make it look like this function, right? So if I add a 3, which is great, so you can't just add 3 on the equation. You need to add it to both sides. So you are basically solving f of x is equal to L, where L is now equals to k plus 3. Now solve this equation. When will you get 3 distinct roots? You will get 3 distinct roots when the horizontal line cuts in between the turning points. Isn't? You will get distinct roots, 3 distinct roots, different roots. Now if you cut in between the turning points, obviously you can see 1, 2, 3 points. And anywhere in between, watch here. I'm going to slide this horizontal. Anyway, if I go below the turning point, I have a problem because the horizontal line is cutting the graph once only. If I go above the turning point, it's only cutting once. I have to be in between the turning points. So in between -9 and 100 over 27. So I need to say -9 and 100 over 27. Okay. So now you don't need to say f of x is equal to L. You can say f of x is equal to k plus 3. Right, so let's just keep it as k plus 3. So now you can say k plus 3 needs to go here, not k, because the value of k needs to be between -9 and 100 over 27. So it's not k plus, it's not the value of k now, it's k plus 3. So you need to put plus 3 here. Now you're going to minus 3 from both sides, so minus 12. And what's 100 over 27 minus 3? 100 over 27 minus 3. It's a two-sided inequality. I'm getting 19 over 27. Right, and that's why it was 4 marks, because it's challenging. Right, so I hope I kind of like covered like 90% of the knowledge in finding the equation of a cubic function, right, so far. But obviously you can get much more difficult problems. It's just a matter of moving the horizontal line and trying to understand the problem and look at the form, right? For distinct roots, the form is f of x is equal to L, or f of x is equal to k. That was a form. Let me change this L back to k, right? That's your original form. Anyways, moving on to the next question. Okay, now we're going on to IEB type questions, right? So this is coming from IEB, the supplementary exam, May 2021. This question here. Right, so we have g of x. Now, be careful because now look at the type of function that they give here now. They're giving a cubic function mixed with the, what you call, cubic function is mixed with a hyperbola. When you do IEB problems, you find lots of, you know, you'll definitely build your knowledge because they have some difficult problems here. It's like level 3 and level 4 type question. They hardly have like basic level. See, look at the questioning technique. It's like 6 marks, 3 marks, 3 marks. It carries lots of marks. Right, so those are the 3 questions. Now, look at the information that was given here. So we have the diagram shows the graphs of g of x, right? So it's only like a simple graph, but it's less than 1. What does x less than 1 means? Remember hyperbola, it has quadrant. This is basically, it was drawn in quadrant 3 and quadrant, because the vertical asymptote is at 1. See, x is equal to 1, there's a vertical asymptote here. So that should be 1 somewhere around there. So I think the value of a is positive because it's in quadrant 1 and 3. So don't worry too much on the hyperbola, focus on this function. The graph G has the x-intercept at -2 and 0. This is a graph of G, -2 and 0. That's -2. And the graph of f and g share a common y-intercept of 0 and -2 right here. Okay, so obviously with this information, with -2 and -2, obviously you can find the entire equation of g of x. And you can also find the f of x, the t value, isn't? Because the cubic function what's the value of t there? T is a constant, right? So the value of t is -2. Determine the values of a and q. So we know the value of t is -2, so we can say t value is -2. So I think this was more on functions. They want to test you on functions, all right? So the x-intercept, to find the value of a and q, you just need to substitute these coordinates inside this function. So remember the function g is y equals, the function g is, okay, so we got t equals 2, that's great. Move on to the next part. That was the first part solved. So now we know the function g is y equals a over x minus 1 plus q. And one coordinate is given at -2, 0. So you're going to say at -2, 0. So the y value is 0. Uh, the y value is 0. The x value is -2. So a over -2, -1 is -3 plus q. I will take the negative. I will take the q over. I'll take a over -3 over to the other side. So I will get a over -3 is equal to q. You can't say -3 now because the negative is next to the division line. Because I'm taking the negative, the entire thing with the negative onto the other side will become positive. Now I will cross multiply this equation. So I will get a times q is equal to 3. So this is equation 1. Now what's equation 2 is y equals, I need to substitute the y-intercept now, 0 and -2. G is also y equals a over x minus 1 plus q at 0 and -2. I guess this is a basic function question in grade 11. Substitute -2 in the y, x value is 0, so a over -1 plus q. And this is easy because -2 is equal to -a plus q. And I thought it will be a simultaneous equation. It's supposed to be plus q. So what's the value of q here now? The value of q is taking the a over, so the value of q is -2 plus a. So this is equation 2. Take equation 2 and substitute there. So replace q with a minus 2. So a into, remember, a minus 2 is the same thing, right? So I took the negative a over. Let's write it as a minus 2 is much better, right? So q is a minus 2 is equal to 3. Make a quadratic and solve. And remember, the value of a has to be positive because this graph is in quadrant. You had a graph there. There's a vertical asymptote which is at x is equal to 1, right? So the graph was in the first and third quadrant. So remember, the value of a has to be positive. So you're going to take the positive answer for a. Let me take all those lines out. Right. So expand this. You're getting a squared minus 2a. Bring the 3 over. Minus 3 is equal to 0. So you got a minus 3 into a minus 1 should be plus 1 is equal to 0. So the value of a is 3 or the value of a is -1. I'm going to reject this. Right, a has to be positive. So that's the accepted value. So if the value of a is 3, what's the value of q? Q is equal to 3 minus 2, which is 1. So great. And you can clearly see that this value, the y value has to be 1. The value of q has to be 1 because that's the horizontal asymptote. Okay. Any questions? Value of q is 1. So we got this implies A is equal to 3 and the value of Q is equal to 1. Next question. Determine the values of X for which the graph f is concave down. Because they share a common y-intercept, we already had that. So when is it concave down? When the double derivative is less than 0. So very easy peasy question. Right, so we're solving part B. So we know f of x is equal to x cubed minus 3x minus 2 because common y-intercept, right? And we said that at the beginning. F double prime x, when we want to find concave down, is double prime x less than 0. So what is f prime x? 3 times 1 is 3, x squared minus 3. Wait a minute. There was an x squared here. No, there's no x squared. It's x cubed minus 3x. So that's 3x squared minus 3, right? Double prime. So 3 times 2 is 6x. And the double derivative must be less than 0. Remember, the derivative of a constant is 0. So 6x less than 0. So x is just less than 0. And x less than 0 gives me when the graph is concave down. We want concave down, not concave up. Now let's check if that is actually true. Yes, it is true because look at this. This is the point of inflection and it's concave down when the value of x is less than 0. It is concave down here. It's concave up after 0. Less than 0, it is concave down. So that is true. There, problem solved. Next one. For what values of k does f of x equal to k have 3 unique real roots? So that's very easy peasy. 3 unique real roots. Now, how are we going to solve 3 unique real roots? Let me recopy the graph. How are we going to get 3 unique real roots? So first of all, for part C, I need the turning points here, okay? What's the turning point here and what's the turning point here? And then use a horizontal cut to check. Right? So I need the turning point values. So what are the turning point values? You need to find the first derivative and make it equal to 0, right? What was the first derivative? 3x squared minus 3 is equal to 0. So we got first derivative is equal to 3x squared minus 3 is equal to 0. Now, you're solving this equation equal to 0. So you're going to take out 3. So you'll get x squared minus 1 is equal to 0. X plus 1, x minus 1 is equal to 0. Difference of two squares. So x is equal to minus 1 or x is equal to plus 1. Now we need to check. We already know that this point is minus 1, 0, right? And this coordinate is 1 and we don't know what the y value is. We need to check. So this is y value here is already 0 because it's already on the x-axis. And what's the y value here? The y value here is substituting into f of 1. Now what is f of 1? 1 minus 3 minus 2. So that's minus 4. 1 minus 3 minus 2 minus 5 plus 1 minus 4. Yes, minus 4 is correct. 1 and negative 4. Right. So now how should you cut? Because they said for what values of k does f of x equal to k have 3 unique real roots? Unique real roots means different roots. So it's just between the y values of the turning point. So between minus 4 and 0. And so we did this question before. And we already got the form f of x is equal to k. The form is already displayed there. So this implies the answer is between minus 4 to 0 because they said unique. Unique means distinct, different. So between minus 4 and 0, you'll get when you're solving this equation, you'll always get 3 different roots. Okay, if you go above the turning point, what happens? You get 1 real root. The cubic function cuts this horizontal line once only. You go below the turning point, the cubic function cuts the horizontal line once only. But in between the turning points, in between the turning points, there's always three distinct routes. Can you see? And what does the value of k mean? Value of k means the y values. We are looking for y value answers. Don't ever put -1 to 1. That's incorrect. Okay, we want y value answers. Y values of what? Most of the time, turning point values. Right? So great. That was a nice IB question. Now, I have one more IB question, right? We're going to go through all this quickly. So now this is coming from the supplementary 2024 paper. I'm not taking questions from final papers because I want you to solve them at a later stage when you're preparing for finals. I'm taking more difficult problems because supplementary, right? Now let's see. You are given the function g of x, which is 3x plus c, and you are given the function f of x, which is minus 2x squared plus 15x. If g is a tangent to f. Now what is, if g is a tangent to f? Clearly, this f of x function is minus 2x squared plus 15x. It's just a parabola, right? We need to visualize what we are doing here, right? It's a parabola function. Obviously, there's some turning point there. You can even find the turning point of a parabola by using derivatives, right? And 3x plus c is basically a point of tangent here somewhere around here because it needs to be sloped. It can't be on the other side now. If you draw on the other side, the gradient will be negative. We don't want negative gradient. We want positive gradient. So they're telling us that is a, so the point of contact will be somewhere around there. If G, this is G and this is F. If G is tangent to F, find the coordinates of the point where G intersects the x-axis. So where does the line G intersects the x-axis? I don't know, right? So I want to find the equation of G. In other words, I need to find the value of C, right? If I find the value of C, then only I can find the x-intercept because I want the x-axis. Now, what's the theory behind point of tangency here? Tangency. So if you go to the initial theory that I did, number 4, what's point of tangency theory? F of x equals g of x, and at the point of tangent, the derivative must be equal to the gradient. So let's see. We don't even have a point of contact here, right? So, but now if you find the derivative, it must be equal to the gradient, then you can get the point of contact, right? So C3 and this one. Let's find f prime x. F prime x gives us the gradient function. So 2 times minus 2 is minus 4x, right? And the gradient of 15x is plus 15, right? Now the gradient must be equal to what? The gradient here. Because how did you get the 3? By substituting inside the gradient function. This is the tangent line. So how did you get the 3? You got the 3 by finding f prime x is equal to 3. So there's my f prime x. It must be equal to 3. Now solve. Take this 15 over. You're going to get minus 4x is equal to 3 minus 15, which is minus 12. Therefore, x is equal to 3. Yeah. So now we have a point of contact, which is 3. X is equal to 3. We have a point of contact, which is 3. So now, what is the y value at the point of contact? The y value at the point of contact is substituting into f of 3 or g of 3. Same thing. So at point of contact, which is 3, and we don't know what the y value is. We know we have something. We got f of 3 or g of 3. F of 3 and g of 3 are both equivalent because at the point of contact. So f of 3 must be equal to g of 3. But now g of 3, I can't find. But f of 3 I can find because the full equation is given. So now I can get a y value at the point of contact. So what's f of 3? Substitute 3 inside the f function. So minus 2 times 3 squared plus 15 times 3. And I've got 27. So I know the point of contact that is 27. So great, 3 and 27. Now we can find the equation of this tangent line because we only have a gradient which is 3. So we got y is equal to mx plus c. So we got y is equal to what's m? M was the gradient which is 3x plus c at what's the point of contact? 3 and 27. So take 27 and put it onto the other side. And you got 3 times 3, which is 9 plus c. So this implies the value of c is 27 minus 9, which is 18. So now I have the equation of the tangent, which is 3x plus 18. Now 3x plus 18 is a tangent line. When will it cut the x-axis? It will cut the x-axis, when the y value is 0. So 3x plus 18 is equal to 0. So x is equal to minus 18 divided by 3, which is negative 6. So therefore, the coordinate will be minus 6 and 0. You guys understood that, guys? So the of this problem is about understanding point of tangency, right? What's happening at the tangent point? If you find the derivative, it must be equal to that value. That's how you need to find that x value first, the point of contact first, and then you can solve everything. Any questions? No questions? Excellent. So that was 5 marks. This question over here is 7 marks. Look at this. And that ends it off there, right? So this is the entire section of this calculus was about 21 marks on graphs. So that was just tangent point. Now let's move on to the next one. We need to understand the whole thing because it's 7 marks, not playing. So see what they're saying here. The diagram below shows a section of a rally track from A through M to B. Rally track from A through M, right? And then to B. Modeled by the cubic function. There's a cubic function here, h of x, ax cubed plus bx squared, right? M is a point of inflection. Okay, lucky they told us what the point of inflection is. So we know how to find the point of inflection. H double prime x is equal to 0. So that's easy. And P lies on the y-axis. Point P is on the y-axis. Now what is M to P to B? To M to B. Okay. MP is a horizontal. MP is horizontal and 1 kilometer long. So MP is horizontal and 1 kilometer long. Because it's horizontal, it's parallel to the x-axis. So because it's 1 kilometer long, so we know what this thing is. We know what the coordinate of M is, 1 and y value. We don't know what the y value is. So this is important information. I filled it in the graph as well. The point B is 2 and 40 and lies on H. Okay. That's fine. We can see there's a y-intercept and x-intercept of 0 there as well. The y-intercept is 0 and it clearly is that's represented there. Let's look at the first question. Determine the values of A and B. The values of A and B. So we want to find the value of A and B there, right? How are we going to find the value of A and B? We know that the double derivative must be equal to 1 because of this 1 over here. It's not 1, it's negative 1. Be careful, right? Because it's on the other side, not 1. If we find H double prime X, that answer must be equal to, yeah, so we can solve it. We have to use simultaneous equation. So solution, let's find H double prime X, what the information was given about the inflection point. So what is h prime x? H prime x is equal to 3ax squared. You have to differentiate what you have. So 3 times a is 3a x squared plus 2b x. What is h double prime x? H double prime x is now equal to 2 times 3a is 6a x plus 2b, right? And that must be equal to 0. But now it's only equal to 0 if the value of x is 1. At x is equal to 1. At x is equal to 1, that's where the inflection point is. Not 1, sorry. So I need to substitute -1. Remember what that -1 is telling me? That -1 is telling me h double prime -1 is equal to 0. It means that there's an inflection point at -1. So h double prime -1, that has to be 0. So if I put -1 here, I will get -6a plus 2b is equal to 0. Let's simplify this equation. I will get 2b is equal to 6a. So b is equal to 3a. Let's call this equation 1. Now, how are you going to set up equation 2? If you're looking at this entire cubic function, don't put 0, 0. Go to 2 and 40. Take the value of 2 and 40 and put it into h of x. So we know h of x is equal to 8 times ax cubed plus bx squared at 2 and 40, because the value of 2 and 40 lies on the graph of h. So the y value is 40 and the x value is 2. So 2 cubed is 8. 8a plus 4b. Right, so now we got 8a plus, divide the entire equation by 4. Yes, so that's 10, 2a plus b. And that's equation 2. But we already know that b is equal to 3a. So 2a plus 3a is 10. So 5a is equal to 10. This implies a is equal to 5a is equal to 10. So a is equal to 2. If a is 2, then b is 6, because 3 times 2 is 6. Right, so we got the values of a and b. Right, so that was a nice question. So now you can get the entire equation, right? So a is 2, b is 6. Great. What is the next question you're asking us for? Next question is asking us for find the straight line distance. Find the straight line distance PB. P to B. How are we going to find P to B? Because that point is 0. What did they tell us about P? P lies on the y-axis. MP is a horizontal line. We can find the horizontal, we can find this distance here. We can just apply, see what's happening here now. You can think about this triangle. Should we use a triangle or Pythagoras? Ah, okay, okay. I see. I see what they're trying to do here. See, see this line here, -1. We can get the coordinates of P here, right? The coordinates of P is 0 and something. Okay? So to find PB, distance P to B, that's what we want. But going to get the y value, we can substitute -1 in the original function because we got h of x. So what is h of x? H of x is 2x cubed plus 6x squared. 2x cubed plus 6x squared, a, b. I substituted from the previous problem. Now, at -1, what's the y value? It's -2 plus 6, which is 4. So this value over here is 4. Okay, so 0 and 4. So this coordinate here is 0 and 4, and that coordinate is 2 and 40. So you can just use the distance formula. PB is equal to square root of 40 minus 4 squared plus 0 minus 2, or 2 minus 0, same thing. Right. So 40 minus 4, you can just use a calculator and get this, because that's 36 squared plus 4 squared. Square root 36 squared plus 2 squared, which is 4. 10 root 13. 10 root 13 yeah, 10 root 13, or you can use decimal values, 0.06. And that looks right. Okay. You can type out the whole thing as you want. 40 minus 4 squared, 40 minus 4 squared, plus 2 minus 0 squared, plus 2 minus 0. I'm not going to put minus 0, obviously. Yeah, so 10 root 30. Correct. All right, so nice problem, clear marks. See, I expected the first one to be a simultaneous equation. Yeah, because usually question involving 6 marks, 7 marks in cubic graphs involves simultaneous equations. What is this? This is sketching a function. See how you are sketching this function here, right? So part C, this was 5 or 4 marks. Sketch graph of f of x. So you must sketch the full cubic function given these conditions. What does f prime 3 equals 0 means and f prime 5 equals 0 means? The derivative, the gradient at -3 is 0. In other words, it's a horizontal tangent, or it's a horizontal line. In other words, you've got a cubic function, right? I don't know whether the value of a is positive or negative. I'm just assuming positive. We can see that one point is -3 and another point is 5, the turning point, the x values of the turning point, right? F of -3 is 5. So I'm putting some values here. F of -3 is 5, right? And f of 5 is -3. Hey, guess what? So this is a positive cubic function because I can't get anything else. They're telling us at -3 is a higher value, and at 5 is a lower value. So this f of 5 is over here is basically a minimum, and that's a maximum by substituting. So there, I kind of like have a cubic function. F has 3 distinct real roots. Label the turning points and the point of inflection on your sketch. So I can just draw this cubic function here now. I'll see, kind of like using a cheat method. I'm going to take the same thing, right? Paste it here and just expand this. So see what I'm doing now. There's my cubic function. And I'm going to draw, it has 3 distinct roots, that cubic function. So I'm just going to draw the x-axis somewhere here. Right, that's my x-axis. And where's my y-axis now? The problem is to draw the y-axis. That's -3. Okay, let me take this out and looking bad. Let's draw the axes actually. And so I'm just checking the points. I have -3 and 5, which is somewhere around here. And I've got 5 and -3, somewhere around here. So now what's the x inflection point value? X inflection point value is -3 plus 5, stationary point 1 plus stationary point 2 divided by 2. You're taking in those 2 points and dividing it by 2. So minus 3 plus 5 is 2, 2 divided by 2 is 1. So the inflection point is somewhere around at 1. So I'm going to draw the cubic function here. They didn't say anything about the y-intercept, right? I can't turn it here now, right? So, okay, that's just a rough cubic function. And I'm going to put the inflection point at 1 here, all right? Inflection point is at 1. That's where my inflection point is. Yeah, that's good enough. And this here has 3 distinct roots, x1, x2, and x3. And that's my inflection point. Right, so my inflection point x value is 1, right? X2 is here, x1, x2, x3, right? And that's my cubic function. Label the turning points and the point of inflection on your sketch. Make sure that the graph is positive, right? The graph looks like this because the value of A is positive, max and then min, max, then min, and then, yeah. Right, so this is great. Last question. See, again, they are asking questions about this now, about roots. If g of x is equal to f of x plus t, what is g of x? If g of x is equal to f of x plus t, what values of t? Oh, okay. So is this function over here? F of negative 3 is equal to 5 and f of 5 is equal to negative 3. Okay, we only need to worry about the turning points, all right? So we are looking at this function here. If g of x, that's another function, all right, is equal to f of x plus t, what values of t will ensure that g has exactly one real root? G has exactly one real root. G of x is equal to f of x plus t. Why did they say f of x plus t? But what is g of x? Of x plus t. They didn't have g of x before this, right? No, that's a separate question. If g of x is equal to f of x plus t, so I have a function here. So what does the plus t mean? It means you are shifting the graph in such a way that, yeah, you are basically shifting this graph in such a way that it must have one real root only, right? At the moment, it has 3 distinct roots, okay? Ah, that's what the question is about. How must you shift this graph in such a way that this function will only have one real root? So this is based on this graph here. So one real root. So let's try to shift this graph. I need one full wave, right? So I'm gonna work on the same graph, but I'm just gonna trace this for you so you can see what I'm doing. Now you must tell me when I will get one real root, okay? At the moment, how many real roots I'm getting now? 1, 2, 3. Let me change this color. That one, right? Watch this graph. I have to move the graph. There's a transformation question, right? So the graph is originally there. Now I'm moving this graph in such a way that it must have one real root. So if I move this vertically down, What does the plus t mean? What does this plus t over here mean? F of x plus t. You can only move it up and down. So if I move it down below 5, if I move it down, now it only has one real root, okay? It's cutting the x-axis once only. So I need to say the value of t must be less than 5, 5 or more. Value of t, you should shift it down, so minus 5. So the value of t should be less than -5. If the value of t is -5, then it's going to be sitting on the x-axis. But if it's less than -5, it's going to go below the x-axis. So that's correct. So you need to move this 5 units down. So -5 or less than 5 units down. That is correct. Now the next one, tell me now how many real roots we have. So this is a level 4 question. So now if I move this value up more than 3 units, so if I move it more than 3 here now, or t is greater than 3, I need to say plus 3. If I add 3, then it's going to be sitting on the x-axis. So if I say more than 3, then it's going to go beyond the x-axis. I hope you guys understood everything. Mishka, we good? You understood everything?